Welcome, everyone. My name is Maciej Szulik. I'm together with Sean over there, chairs for the SIG CLI. I'm also holding the role of the SIG CLI technical lead, along with Phil Whitrock. And
I'm Juan Vallejo. I'm a part of the SIG CLI, and I'm here with Maciej to talk to you about plugins. Now, to get started really quickly, how many of you have written a plugin in the past? There we go. We have 3, maybe 4. How many of you have written plugins before KubeCTL 1.12? I am so sorry. We've broken you with current updates, but hopefully we will get to introduce to you the new mechanism, briefly talk about what's new and what's better, and hopefully get you all indoctrinated into writing plugins under this new powerful mechanism.
okay, so to quickly bring us on the same page, what are plugins? Well, plugins are nothing else like nothing more than just an extension to the kubectl. We've seen that the entire Kubernetes ecosystem is growing rapidly. We are able to extend any part of Kubernetes. To come up with the same options in the kubectl, we created the plugins mechanism. And the plugins mechanism, actually the initial one, was created back in the spring of 2016 by a colleague of mine from Red Hat, Fabiano France. Unfortunately, the initial version introduced in 1.7, Kubernetes 1.7, was very simple. And at the same time, it required plugin authors to write a YAML file describing how the plugin will be executed, what is its description, and a lot of boilerplate that was unnecessary. From our point of view as the kubectl maintainers, it required us to have additional logic in place to be actually able to execute the plugin. That's why over the couple next releases, we reevaluated the same mechanism. We looked at the plugin mechanism available in Git. We looked at Helm and a couple other places, and we figured out that we are going to change the mechanism. We are very sorry to all the authors that wrote plugins predating the new mechanism, because the majority of them will be in some way broken. But if they were a regular binary applications, there is a great chance that they will keep working. The only good thing, well, probably one of the good things of having the new plugin mechanism is the YAML files describing your plugins in the new architecture is not anymore necessary. So, like I said, we looked at different solutions. We looked at what other programs are using for pluggability. And we come up and focus on 3 major areas. One of them was usability. We wanted to have something that will be simple, both for us to execute as from the kubectl standpoint of view, as well as for the plugin authors to easily create the plugins and eventually help them with actually writing those plugins. We focused on discoverability. Although initially the ideas that we had was mostly around the discoverability on the machine, we also spent some time just recently working on plugin index, plugin management, and thanks to awesome work by Ahmed and a couple of folks from Google team around managing plugins. There is one thing that I put a huge question mark next to, which is extending or overriding the built-in commands. This is one of the discussions that we keep having around the possibility whether we want to support the ability to override the built-in commands, to what extent, how much we want to allow people to change the built-in behavior. So if you're interested in, come join us. We are more than happy to hear your opinions around the topic. So, like I said, in 1.12 we introduced the new plugin mechanism, and just in 1.13 this mechanism, thanks to your all wonderful support and feedback that we gathered, we all agreed that the new plugin mechanism is mature enough, and we've graduated it to beta. So, how to write a plugin these days? It's actually very simple. Literally any binary that will be living in your path, which prefix will be kubectl dash, is a plugin for your for kubectl. We got this idea from the Git subsystems. It's working very well for them. There are some twerks, and Juan will be talking about the naming conventions because we diverged a little bit from what the original Git mechanism has, but that's a separate thing. Additionally, we introduced a library. So over the past couple months, we've spent a decent amount of time going through the entire kubectl code base, and we've extracted several components that we found useful and extracted them as a separate library, which exists in the Kate's repo, which is CLI runtime. The CLI runtime library provides functionalities to obtaining and managing REST client, for reading configuration, it also provides a set of common functions that we also use in the kubectl itself. Like I said, over the course of the entire refactoring, we've also managed to unify the experience across all of the commands. That includes, for example, printing stacks. Beforehand, there were some discrepancies between commands, meaning that different commands would be printing objects, Kubernetes resources, in non-consistent way. While refactoring and extracting the functionality into a separate library, we actually went through all of the commands and ensured that every single command works the exact same way. Along the way, we also extracted a set of helpers that we think might be useful for potential kubectl plugin authors. And to Duckfoot, what we created, we are actually the first consumers of the CLI runtime, we as a kubectl itself. So that's a very important thing. Okay, Juan.
Okay, so we'll begin with the proposal, which introduced the new design behind the plugin mechanism. Feel free to take a picture, or we'll make the slide deck available, and you'll be able to access that proposal. It details what we aim to do and what we aim to stray away from behind the introduction of the new design. So, as far as the naming structure goes for the new design, we essentially treat your plugin executable as basically through its file name. We assume that your plugin will implement its path based on the file name of its executable. So what we mean by that is that, as you can see, with an executable in your path named kubectl-foo-bar, that executable will essentially be called by kubectl whenever the kubectl-foo-bar command is executed in the command line. For plugins that wish to implement commands with dashes in their names, we've added the ability to essentially interpret underscores in the file name to map to dashes in a command line command. And yeah, essentially we hope that by having a simple naming structure and no other configuration files, that writing plugins would be a breeze. So the path is something we pretty much intensely look at when determining which executable will be called when a command is executed in the command line. So, for example, given two executables in the command line, one called kubectl-foo and another called kubectl-foo that exists somewhere else in the path, we will disambiguate which executable will be called based on whichever one appears first on your path. So if the first location appears first, then that one will always take precedence. And we will tell you which one takes precedence as well via a command that we've introduced as well called kubectl plugin list, and it is available as of 1.12. So what about executables that overshadow essentially other executables with shorter names? So let's say, for example, you have two executables. One's called kubectl foo-bar and another called kubectl-foo. Well, in this case, which one would be called first? Naturally, we would probably think whichever one comes first. But in order to allow us to provide plugin authors the ability to implement command trees using different plugin executables, we've made it so that we essentially, in a greedy manner, always choose the longest file name first. So in this sense, kubectl-foo-bar will always be executed and will always take precedence over kubectl-foo, even if kubectl-foo comes first in the command line. This also allows us to provide you with the ability in the future, as Maciej said before, to potentially override or even extend existing kubectl commands. We welcome your discussion on this topic. We are actually currently having, and will begin having future discussions on this matter as well. But we figured that having this design extensibility right now would prove powerful in the future. So some code examples. As you can see, we've taken this code snippet from a sample CLI plugin available under the Kubernetes org right now. So you go to kubernetes/sample-cli-plugin. It is a repo containing sample code that you can compile and run right now and use as a plugin with kubectl. It's as simple as a few lines of code. Essentially, the gist behind this all is we wish for the new plugin mechanism to promote any plugins and clients that are written to behave and feel the same way as existing kubectl commands. So a few key imports that we see in the sample CLI plugin, if you inspect that repo, are some client Go tools, such as client CMD, which allows you to manipulate a user's kubeconfig file. We see client CMD/API, which provides API types that you can use to represent, in this case, kubeconfig information. And we have some generic CLI options, which are provided as part of the CLI runtime repo, which you can think of as a mini SDK to assist you in your plugins. As Maciej mentioned, we aim to honor essentially the same the same structure and the same set of tools in CLI runtime that we ourselves will use in kubectl. So if we're broken, you're broken, and vice versa. So we aim to keep this healthy at all times. So the main design pattern we've chosen for the CLI runtime repo consists of a simple struct containing a few fields which determine which flags are specific to, for example, in this case, configuration. So given a configuration struct of flags, you're able to call an add flags method which binds specific flags. It essentially binds those flag values to its fields. And then once command line flags are parsed and the user has provided flag values, you are then able to, in your program, ask of specific functionality from this flags struct. So in this case, you're able to, once flags are bound, ask for raw kubeconfig file data. And with that data, you're able to manipulate it. You're able to save it right back. You're able to use it in your program. And essentially, you're able to do it in the same manner that we ourselves do in kubectl.
Okay, the future. I'm not going to focus only on the plugin mechanism, although probably you've noticed that one of the main discussions that we are having at the moment, and that is probably one of the ones that we want to have resolved by the time we will promote the plugin mechanism to a stable feature, is figuring out how much of the built-in commands, which built-in commands, and to what point we want to allow plugin authors to override. There are so many concerns There are so many discussions that we're having in our bi-weekly meetings. If you're having your own opinion, feel free to join us. Find us on Slack. There will be a Slack channel in the next slide. You can also find us during KubeCon and talk to us. Give us your opinions. We're very open to listening what people think, what they want to do with kubectl. If you're having some problems, ideas, thoughts about the kubectl itself, feel free to either find me, Juan. There's Phil in the back. Actually, he joined. Sean is right over there. We are spending a lot of effort currently to actually extract kubectl so that its release cycles are not tied to the Kubernetes cycles, so that we can actually move faster with the development cycles of the kubectl. Sean is this close of actually extracting kubectl. If everything goes well, we will have kubectl in a staging repo, which is like a mid-step until we get to the separate repo within 1.14, and hopefully 1.15 will be the first release where we will be working from the kubectl repo. The current contents, that's the thing that we also need to solve. If you're using the current contents of the kubectl repo, talk to us, find us. We're very interested in why you're using it. We need to have a closer look whatever currently exists within the kubectl repo, because we need to figure out what to do with the functionality that it is, whether the functionality that we currently have, either through CLI runtime or within the kubectl itself, is able to fulfill your needs, and so that we can almost entirely drop the functionality that is currently in the kubectl repo that exists these days. Other than that, there's a lot of refactoring going on. So I'm already very sorry if you will be struggling with some of the refactorings over the next couple weeks. Like I've mentioned before, we've gone through a major refactorings in the kubectl repo over the past releases. One of the reasons was we wanted to extract the kubectl repo to a separate repo. We've managed to extract the CLI runtime to support not only us, but also plugin authors. So all these small steps, which are somehow very big from one point of view, because we're touching literally every single file within the kubectl tree, they're aiming to simplify both the user experience as well as the developer experience. If you go through any of the commands these days, you'll probably notice that a lot of them are following a certain pattern where we, like Juan said, we have a structure that maps to flags that the command does, and every single command follows a certain pattern where we complete the structure, validate the structure, and run the actual command. We're very open to folks helping us with this effort. If you have some time, if you're interested in participating in SIG CLI, in actually making your hands dirty and working with it, we're very happy to have you on board and help us with these efforts. So that's probably most of it. Like I mentioned, we are on the Kubernetes SIG CLI Slack channel. If you want to find us, all of us are there. You can either, if you're very shy, you can directly find me under Soltis. Juan's under his regular name. Sean is Sean S. Philip is under regular FP Whitrock. I think I'm the only one hiding behind some cryptic name. You can also, yeah. Also, we have a Google group. The volume of the emails is very low on that group, so you don't have to be afraid that we will be spamming you a lot. If you have any questions at this point in time, we're more than happy to answer you. If you're shy, I'll be outside of the room in a couple of minutes. You can just talk to us. Thank you.
Thank you.